article quickly. It's another diversion from my patent and historical article stuff. I just wanted to go over this real quick. This article, Intrigue versus Risk, Clinic-Based 3D Printing of Prosthetic Devices, really was a great title by Barry Hand and Michael Levezzo. I think he's from Frittles. So anyway, I wanted to go through this article real quick. They talk about, as the popularity of 3D printing gains momentum in the prosthetics industry, some O&P professionals have considered purchasing a 3D printer to print their own custom-fitted sockets. While 3D printed sockets can save time and money and provide a quality product and can be risky and difficult to operate these printers without constant access to someone with professional experience and knowledge on the subject. This is true. 3D printed sockets can save time and money and provide a quality product. Can be risky and difficult to operate these printers without constant access to someone with professional experience. I guess to be debated. The riskiness can be frustrating for sure, and you do have to have some know-how and some technical expertise on the 3D printing side, but risky and difficult. It's just different. Traditional fabrication can be risky and difficult as well. Lamination using cast saws, regular saws, band saws, all that stuff, but you just have to know how to use the tools. So interesting statement there. In-house versus sourcing. 3D printed sockets are less expensive, require less fabrication time, and can combine flexibility with strength and stiffness in comparison to those made traditional methods. Not all the way true, less expensive. I use a copolymer socket. The distal end, cost me about, depending on which one I use, $20-ish, but just for the copolymer, you're looking at $7-8, and a quick vacuum forming, start to finish, under 45 minutes, really to get the final socket out. So not less expensive, don't require more fabrication time. It's just, it takes less man hours, so the machine is doing your work. Flexibility with strength and stiffness, again, possibly, but a good technician knows how to use plastic and vacuum form it appropriately, whereas you can build that in digital fabrication sockets, but not completely a true statement. The materials used in 3D printed sockets can be reformed and reshaped after being fabricated. Very true. When we 3D print our sockets, we use a PETG, and it does a really nice job. It actually acts a lot like copolymer or polypropylene. Individuals using 3D printers are finding that they get frustrated with their results. Again, probably true. It does take a lot of work to get there. I feel like there's a lot of not great information, especially on using some of the consumer printers and people trying to use small nozzle printers to print these sockets. So probably true there. Stratasys, one of the pioneers in printing, has identified 4 considerations when choosing between buying a 3D printer and versus outsourcing. So advanced equipment and materials, definitely true. There are some very expensive printers out there that print some neat stuff. And then every time you use a new material, you have to figure out how that works. So definitely very true on that. Investment risk can be a significant capital expense. People were spending $100,000 plus on a carver, so I guess it depends on what your definition of significant capital expense. I suggest to get started, some of the Lulzbot printers are great printers to get started on with large nozzles. You're looking at about $3,000 expense there just to get going and to give it a shot, and there's a lot of support on that. Manufacturing ability. Many parts of a prosthesis are complex and require special build styles or specific materials. In-house operations may not be able to achieve the desired look, feel, and function. Uh, true, a little bit. They are complex. Trying to combine organic with dimension shapes is difficult, but it is not unattainable. Additive manufacturing expertise. Expertise is the differentiating factor in creating a quality part or product. 3D printing knowledge requires knowledge of what is required to finish the part and the equipment used to accomplish that. Totally agree on that. You definitely need expertise, but you can gain that along the way. I think one of the things that has made me a better clinician is actually having to think about the end product, whereas a lot of prosthetists were really good at making things work after it's fabricated. With additive manufacturing, you don't have that luxury a lot of times, so you have to think of everything up front. And just one of the examples of that is I did a little prosthesis for a little girl. I was going to use a Chicago screw. I had to actually create the recess for the Chicago screw for the thigh section in the socket itself, or I wouldn't have been able to do that before. So or after the fact to use a countersink. So very true on that, but I feel like it's really made me a better clinician in the end, and the end product is great. Some of the issues I have with the process of 3D printing are all the different types of filaments that can be used for in the applications of each filament. I mean, yes, there's a lot of different ones. It's kind of like finding your type of resin and fabric that you want to use, whether it be carbon fiber, basalt, or some of the other composites, and sticking with it and making it work. So the same sort of thing with additive manufacturing. Each one of the items have been printed more than a couple times to make sure print quality is good and make sure they will work before using more expensive filament. Again, it's just dialing in your machine and knowing the materials. And it takes a little bit to dial it in, but once you have it dialed in, it really doesn't change after that. And that's also the benefit of having multiple machines that run different nozzle sizes and filaments. If you know one machine does this particular type of filament really well, then you just stick with that, and I mean, it's really a plug and play type of deal. The properties necessary to print an adequate prosthesis can only be achieved through specific combination of printer configuration, careful material selection, and a rigorous process and environmental controls. All true, maybe a little overstated, but definitely true. Most commonly available materials used in 3D printing are brittle and not designed to be used for patient use. I'm guessing they're describing PLA, and it is brittle. And even PETG can be brittle at times if it's not printed right. So, but there's so many other materials that are available that can do just the basic stuff like test sockets and such. So, true, but there are some options. This company, Extremity 3D, uses a proprietary polymer engineered for durability, dimensional stability, and strength. Very cool. I believe it's in the nylon carbon fiber family. But that stuff is definitely very strong. I like it. Specific printer configuration associated with given product is a complex combination of a long list of important variables. Very true. You can kind of tailor those down, and there's a lot of support for a lot of the filaments there, so you have a pretty good starting point. They talk about this table down here: nozzle size, nozzle temperature, feed rate, print speed, bead width, bead height. Uses supports, support material, humidity, print bed temperature, print bed angle, post-processing, curing, power stability, wall thickness, infill pattern, infill percentages, and material preparation. All very interesting. Miscalculation can ruin an end product, absolutely. In professional additive manufacturing companies struggle to optimize so many variables, very true. Simplify 3D, they have a great article regarding the issues. Then there's a comment down here. Another issue I have is the time involved with making sure the print comes out correct. I spent a lot of time looking at the prints for the first hour to make sure that I have good layer adhesion, to make sure it sticks to the printer bed, and you really don't know if it's going to stick to the printer bed until you are about 1 or 2 hours into the print, if it's a large print. Probably the main frustration. And again, this just comes down to setting up your machine, knowing your machine. I am not having these kind of issues as far as wondering if it's going to stick to the bed or what have you. But it's just about dialing in your machine and knowing the materials a little bit. So then we get into software and printer issues. Printing sockets without the right expertise is not just risky, it's inconvenient and inefficient use of time. Boy, oh boy, I don't know what to say about this one. If it can be frustrating, yes, but I tell you, it is nice to be able to modify something really quick, throw it to the machine, and then pick it up a few hours later. So pretty efficient use of time, because I'm able to do my notes and all that kind of stuff. So I'm not exactly sure on that comment there. Choosing a printer that can be the right materials, which must be configured correctly, can depend on dozens of variables. Very true. Maintenance, keep it clear, keep it lubricated. Not super difficult. Backup printer. Having multiple printers, I think, is key and is a tool in your toolbox. Data quality, very true. 3D model resolution, but most of the scanners nowadays, it's not really an issue. Repair a broken STL file. Again, with all the software out there, free software on top of that, not really an issue. Familiarity with software, yes, but not impossible. Adding features or components, embossing, specialized techniques. Yeah, very, very true that there are specialized techniques. Let's see here. 3D printing experts can provide an efficient and effective solution that is not uniformly thick replica of limb scan. Very true. Not difficult to do. It's just something that you have to think about. Sockets must work with the entire prosthesis, not just the fit of the patient. Very true. You've got to get your 4-hole connector, however, in there. Extremity 3D does an interesting job with the BOA system, or the Click Medical system. This picture is just kind of interesting because the flexible inner is lower in the front and posterior and way higher on the side. So I don't know about this picture, but pretty cool idea of what you can do with flexible inner and the BOA system there. The conveniences advertised by vendors of 3D printers are heavily outweighed by the inconveniences, as well as risk associated with using a printer in-house rather than going through a central fabrication facility. Again, it's where you want to spend your time, and learning. I think in the end game, I think it's worth definitely learning about additive manufacturing. If you want to choose to outsource at the end, that's great. But I would tell you that outsourcing right now is not a cost-effective way to do things when you look at the bottom line. If you actually have equipment and are able to do some of these things in-house. Central fabrication facilities offer clinical expertise and customer relationships to provide a 3D printed socket. I can't disagree with that. That's very true. Having a relationship with a 3D printing engineer ensures the designs are communicated properly to produce the final socket. Totally agree with that, but I'd also have to disagree a little bit in that you just really have to tweak that communication. If you're a prosthetist and you know how to operate some of this stuff, it's just nice to be able to put the stuff in that you want. Buying a 3D printer is a big decision and involves a significant learning curve. True. You should plan to dedicate a person to run and maintain the machine, stay informed of the variables. Very true. Patient care. Diagnostics and treatment planning are require a certified process expertise and time, but outsourcing 3D printing can produce a superior outcome by combining prosthetics clinical knowledge with an engineer's expertise in 3D printing. I can't disagree with that statement. I mean, it's a great statement. There is a lot of opportunity to work with engineers as well as prosthetists. So in the end, I mean, this is a good kind of overview of printing. It's a kind of a good marketing piece too for Extremity 3D. But don't be discouraged by the idea that only 3D printing engineers and companies can print sockets. There's a lot of things that I believe that you can do in-house, and maybe not a definitive socket, but for the printing of sockets. So just thought I'd